Hello students, so welcome back. We ended our last video in this series on some practice problems. You were multiplying two binomials together and I brought in radicals, so I want to make sure you feel confident and comfortable on how to go about these problems. So we're going to first look at letter A. So we have 3 square root of x plus 5, and that is our first binomial. And it's being multiplied by 2 square roots of x minus 7, which is our second binomial. So we're going to go ahead and multiply the first two terms together. So 3 times 2 is 6, and the square root of x times square root of x is the square root of x squared. Then 3 times negative 7 is negative 21, and we have the square root of x. 5 times 2 is 10, and we have the square root of x. And then we have 5 times negative 7, which is negative 35. And notice I'm just doing the FOIL process, first, outer, inner, last. I'm going to go ahead and simplify. Using my exponent properties here, I know that the square root and the square cancel each other out, so I am just left with 6x. These two terms can combine together, and I am left with negative 11 square root of x, and then minus 35. And there are no longer any like terms, so that would be my final answer. Looking at my second problem, letter B, we'll do that over here. So we have 4 square roots of 5 plus the square root of 6, again a binomial, multiplied by 4 square roots of 5 minus the square root of 6. And hopefully you're noticing that those binomials are exactly the same, but they have opposite signs, therefore conjugates. So you're already beginning to think, okay, I know my outer and my inner term are going to cancel out. So as I go to solve this, 4 times 4 is 16, and square root of 5 times square root of 5 is square root of 25. My outer term gets me negative 4 square roots of 30. My inner term gets me positive 4 square roots of 30. And my outer term gets me negative square root of 36. And as I go to simplify, the square root of 25 is 5, so I have 16 times 5. My outer and my inner cancel each other out, and the square root of 36 is 6. And if I go to my handy-dandy calculator, and I type in 16 times 5, I get 80. And when I subtract 6 from that, I get a final answer of 74. Now looking at my final problem, I have 3x plus the square root of 2 all squared. So I'm going to go ahead and write that out twice because that's saying this binomial has to occur 2 times. And again, if I go through my FOIL process, I get 9x squared plus 3x square root of 2 plus 3x square root of 2 plus the square root of 4. And if I go to simplify, I have 9x squared plus 6x square root of 2 plus 2. Continuing on, now moving to the operation of division. You can't really see it here because the idea was this was a PowerPoint slide to start out with, but prior to all the little markings I had on it, I had 4x squared minus 9 all over 2x squared plus 3. And the point that I'm trying to make is if you look at this division problem, you kind of notice some similarities, right? You see I'm circling the 4x squared and the 2x squared. You know that 4 divided by 2 could cancel out. The x squareds could cancel out. You may be even tempted to work with the negative 9 and the positive 3. But the idea is that you don't ever want to do this because you cannot divide fractions when there are, plus minus operations present. So you can only divide on top and bottom when you're thinking about a monomial term. You cannot divide out parts of a binomial or any polynomial. So you don't want to separate terms and try to cancel things out. You're not allowed to do that. You'll end up very far from the correct answer. So you actually have to have the same exact thing on top and bottom. So you could have something like 3x squared plus 6 all over 3x squared plus 6. And because you see the same exact thing on top and on bottom, then you could cancel that out. You can even have like a monomial term, and maybe you have the 3x squared plus 6, and maybe that's being divided by 3, times 5x squared plus 7. And the monomial terms can cancel out, but your final answer would still be the 3x squared plus 6 all over the 5x squared plus 7. So you can cancel out any monomial terms or polynomials that are exactly the same. Otherwise, you can't do anything. So in this original problem, I wrote the 4x squared minus 9 all over 2x squared plus 3. There's actually nothing that you can do in order to simplify that, and that would be your final answer. Now going on to the idea of decomposing polynomials. So this is the idea of working backwards. So I've been giving you the binomials and you went through and foiled them and you got an answer, particularly a trinomial. Well, now you're just working backwards. So you're starting out with a trinomial and trying to get your factors back. So different instructors teach this differently. I'm going to take you step by step. So the very first thing you want to think about is what standard form is. We know that it's ax squared plus bx plus c equals 0. And so our a, b, and our c are representing our coefficient and constant terms. So I'm going to use that as I help you understand the steps. So the first step is to multiply a times c. So if you're taking notes, step 1 is to multiply a times c. So in this case, a times c is 1 times negative 6. So that's step 1. Step 2 is to list out all the multiples, all the 2 terms that multiply to the a times c value. So I can have negative 1 and positive 6, positive 1, negative 6, negative 3, positive 2, positive 3, negative 2. Those are all the terms. So that's step 2. List out all the multiples that get you to negative 6. And then I am going to add these all up together. So this gets me 5, this one gets me negative 5, this one gets me negative 1, this one gets me positive 1. So step 3 is add up all these terms together to see which pair equals your b term, which in this case is negative 1. So I'm going to circle the pair that adds to my b term. And then the winning pair is what creates my binomial, x minus 3 and x plus 2. And sure enough, if I go and FOIL this out, I'll end up back at my x squared minus x minus 6. Okay, so pretty cool. Some things I want to know about this method prior to beginning a problem. I do want to have it in standard form, and this only works when my a value is equal to 1. So super important to note as you're taking notes that this method will only work if a is equal to 1. So here's another example. I encourage you to pause this video, try it on your own, and then we'll work it out together to see if you end up at the same solution. So I'm going to start by multiplying my first times last. That's 1 times negative 8, and that gets me negative 8. Step 2, I'm going to list out all the multiples that get me to negative 8. So negative 1 and 8, 1 and negative 8, 4 and negative 2, negative 4 and positive 2. I'm then going to add these all together, and I'm going to see which one adds to the middle value to my b term. And I'm looking for negative 2, and so that is the last pair that I created. So those create my binomials, x minus 4 and x plus 2. And again, you can FOIL that to check your work. Okay? Again, remembering that we were able to do this process because we were in standard form and our a value was equal to 1. Super important. All right. Another example. If you want to go ahead and again pause this video. So when I do first times last, that gets me 25. When I think about two numbers that multiply to 25 and that add to 10, I think of positive 5 and positive 5, because in fact those do multiply to 25 and they do add to 10. Therefore, my final binomials are x plus 5 and x plus 5. And if I did want to rewrite this, I could rewrite it as x plus 5, and all of that is squared. Now you'll notice here that my A value does equal 1, so that's good, but that I am not in standard form. And so when I'm not in standard form, I need to put it in standard form. So in order to do that, I want to be set equal to 0. So all I have to do is bring my 12 on over, and now I can begin going through the same process. So first times last is negative 12. Two numbers that multiply to negative 12 but add to 4 would be positive 6 and negative 2, because those do add to a positive 4. So therefore, my two binomials are x plus 6 and x minus 2. Okay. If you look at this next problem, I'm asking you what's different here. And if you know, the A value is no longer equal to 1. So we're going to have to do a different process. We're going to do something called factor by grouping, and that will be in the next video for the series. But I highly encourage you to maybe reflect if you've ever learned factor by grouping and try to investigate what you would need to do to go through this process. But again, if you need further help, I will have another video in the series to help you with the factor by grouping process. But everything that we've been doing will always work as long as we're in standard form and our A value is equal to 1. So again, I hope you found this video helpful. If there's anything that you need assistance with, please don't hesitate to reach out.